Hello, I'm Philip Stoten. I'm here on the SCOOPstudio at Productronica 2017, and I'm joined by three gentlemen to discuss the topic of reflow. In these process-focused roundtables we're doing today, I really want to understand what the current challenges are for particular processes. So in this case, the reflow process. Got Ronny here from Seho, Karthik from Indium, and Miles from Kick. We'll start with you, Ronny. What's challenging customers, and what are they asking you about at the moment?
I think there is two issues. It's about the thermal mass distribution on the boards. So the big components get bigger and bigger, the smaller get smaller and smaller. So solder the big ones, but don't burn the small ones. There is some limitation in hot air convection. And the other is the voids. When there is a thermal contact necessary to bring away the waste heat from any electrical current flowing around. So the backside must be connected more or less 100%, and there is not any obstacle allowed to get the heat flowing. These are the main issues, and to fight these, one has to be tricky to a certain extent.
Yeah. And I'm really pleased that we have equipment, we have measurement and software, but we also have consumables here because that plays an important role in it. What's challenging you that relates specifically to the reflow process?
I'd say be it miniaturized components or a big board that's got both small and big components. Like Ronny was saying, I see a few key challenges. The first one is as the amount of flux or the paste deposit reduces during reflow, the amount of flux per unit surface area reduces exponentially. So you got to take care of oxidation. More importantly, for components like BGAs and CSPs, the huge problem in the industry is head and pillow and graping, which is an indicator of head and pillow that manifests itself on small components. The next one is voiding. So the void challenges during reflow, the key purpose of a flux is to reduce oxide and give a good bettable surface. But you got volatiles that are involved in this process. When volatiles see heat, they're going to expand. These manifest itself as voids. And how do you engineer the flux to do a few things on the voids? Reduce the lake-sized voids, the big voids, to the small ones, move them away from the center to the perimeter, and by doing all of this, reduce the overall void percentage. So in all of this, the flux technology becomes pretty key. I would also add that in a few verticals such as automotive, vacuum soldering is being looked at with increasing interest. And with vacuum, taking care of the voiding is a lesser challenge. It happens. But now when you have vacuum and when you got liquids, you've got splash, solder balls, and spatter. So again, how is the flux chemistry optimized to address these problems? So that's where we come in.
Okay, and Miles, when you look at it from a thermal profile point of view, you look at it from an analysis point of view, what are you seeing? There's an awareness of the void issue because we've talked about that before, but talk about that and also anything else that's vexing your customers.
Well, where we step in is you have this is a good combination you have here because you have the complexities of the oven and all the settings that it could possibly have, and the complexity of the board and the materials. So you have to kind of combine that. So when you talk about the metrology, is measuring it, but also, okay, after you measure it, if it's not quite right, what do you do next? And so we provide more than just the measurement, is the ability to optimize the process by knowing what the makeup of the materials is or the requirements for the paste and how it has to be processed based on those fluxes and different chemistries that they use, and then the potential settings on the oven, which are in the millions when you look at all the zones and conveyor speed combinations. So we try to, our customers need that assistance, and if I don't have an engineer who's been doing this for 40 years, how do I get this process set up? So on the software side, which a lot of solutions are going towards now, we provide some optimization tools so they can set that process correctly and get it within the very fine window that they have to run in.
Yeah, and it absolutely has to not be an engineer doing it on the line, because it's going to be a different engineer on one shift to another shift. It's going to be different in one facility in one part of the world or another part of the world. That data side of it, I guess, becomes increasingly important. Where do you see that smart factory and that reflow process fitting together, and how do you work in that space?
I would say we have a great relationship with guys from Kick to have monitoring on the oven, to have something on the machine that really makes the monitoring on a very redundant way, feeds back to the oven, and especially in our case, we can just press one button to take their proposal for a new process over, and the machine sets a new recipe by itself. And in this case, just to make bomb-proof that the recipe is right, and if we calculate a virtual profile which is deviating too much, we can use their help to set up a new process and to come deeper in spec again. Yeah. So that makes this interaction sexy in a certain way. Yeah. And the machine does what it shall do. Even if there is some deviation, we find back to the center of the path.
Yeah. And Karthik, from your point of view, you're producing specs with all your solder paste that are kind of creating the challenge for these guys to get within that spec, but also they've got to manage changeover of different board types that will be using the same solder paste. Where can you work to improve that process to, maybe it's the size of the window, or maybe what can you do to ease that changeover and increase that productivity process?
Well, from a material standpoint, our job is to give the customer the widest possible process window. So the material needs to work for the process, not the other way around. The process should not be band-aided to make the material work. So that's the first thing. So from a flux chemistry standpoint, in the context of reflow, to have the widest window, when you take, let's say you take the perfect storm, a big board, heavy thermal mass, OSP, high temperature, long time, air reflow, and now you're talking about, say, O201s as well as big components. So this is a challenge. And now you factor in through-hole components as well, and you're talking about pen and paste, relatively thick board. So when you're looking at all of this, we have a material with the widest window, but also, like Ronny said, as an example with Kick, with their PWI feature, with our process window, we'd be able to say that these are your soak times, these are going to be your times above liquidus, these are going to be your cool down slopes, these are going to be your preheat ramps, which is, anyways the norm. But what we would be able to do beyond that is when we work with a customer, because if they were to say, hey, head and pillow is way more important to me than, let's say, voiding on an 0805. Okay, so specific to head and pillow, we know that based on the flux chemistry, you've got to focus on, a hot soak, where you want it to be in this zone. And if you do too much of it, you could actually start having graping on the smaller components. So being able to engineer some of those very specific parameters and feed it back, makes the customer's job a lot easier, and again, achieve the profile in one shot.
Yeah, so you've got to have the right data from these guys to be able to put that in the program. They want the program and they want that information in real time. They want you to be able to make those changes if there's changes in project planning as well. So you need to be able to provide that data to the line on the fly, so to speak. Where can you add the most value in terms of the reflow process using the Kick solutions?
Well, we have two areas where we see, especially with the smart factory going forward, that we can add value. One is in the NPI, so when they're trying to set up for the reflow process, being able to, if you have a smart factory where something like IPC CFX, you can get into the MES system or some other system and you have the paste and all its specifications. You have information, or like as Ronny said with the Seho oven, we can interact. If we can grab that information ahead of time, we can get them started in the correct recipe quickly. So if they have a lot of customers coming in demanding boards to be set up, they want that to turn around and start production fast. And then the second side is, once you run production, the end customer wants to make sure my board, every single one of my boards, not just the profile at the start of production, but every single board was produced correctly. And so on the fly, we're able to monitor the temperature profile or the production profile of the board within those specifications, and then alert the line or the oven based on the process side. So now you have a combination of process information and machine information combined, and then you can get to the point with the smart factory of doing on-the-fly reactions to that. So I think the combination of all that, especially when you go with the smart factory, gives the customer an opportunity to really build really good efficiencies in their manufacturing.
Yeah, and then we can use, I guess you're using historical data to learn about those processes and improve them and speed them up at the same time. Last question to everybody.
Yeah.
Those are the challenges we have now. What do you see on the horizon? What do you see as the next big challenge for Reflow?
Try to increase the thermal transfer. Even with hot air, there is limitations. We cannot heat like hell, we cannot blow like hell. Otherwise we burn or we empty the board. So it will be tricky to solder some stuff for electromobility, for example. And what's a very important stuff is also the cheaper the PCB material becomes, the more dirt we find in the ovens. This is a big challenge for everyone. This is beyond the process, but it's also a very important issue about maintenance of these ovens, make them run longer and longer without having to open them. So it's also an issue.
Interesting challenges. Karthik, from your point of view, what's on the horizon that you're working on right now?
Like I said, the key purpose of a flux is to reduce oxide, provide good wetting, and get a great solder joint. And the three key challenges we see, which are only going to become even more challenging, are going to be head and pillow, non-wet opens, and voiding. I mean, these are going to be in everybody's minds because packages are becoming smaller, more powerful, and emitting more heat.
So that remains the same. Miles, from your point of view, obviously AI and other issues coming into what you're doing, but any new challenges on the horizon?
I think the big challenge is the push more and more is that not our end users, but the customer at the end is demanding very customized products. So now the production runs can be, they want to try to get in 10, 12 different products run the same day, short volumes and sometimes long volumes. So it's a huge variety. And you know, on the ovens, they already have, there's amazing capability in the oven. The chemistries in the paste, you know, have advanced a ton. So there's a lot of possibilities, the combinations and everything. And being able to manage that where you're doing a dozen changeovers a day and all sorts of different products and combinations. I think that's going to be our challenge, which we look forward to, is being able to be smarter about that, sharing the data and the information, so you can do the theoretical customization of a run of one, and then the next product has a completely different setup and everything, and be able to manage that all the way down the line.
And be able to manage production control and production planning in that. It seems like it's all about, as everything seems to be at the moment, about collaboration, about working together and sharing information, and it's great to hear that you're all partnered on various different projects and doing that. Thanks for coming in to talk to me, and thanks very much for your time. Thank you.